We came to Clemson University for two reasons. One, technology. Clemson is making F1 vehicles that are basically autonomous, and that's kind of a big deal for us. IndyCar, sorry. But that's a big deal for us. So we wanted to have a chat with them, and unfortunately we got here at around 6 o'clock at night, so there wasn't really much of an opportunity to mingle or meet and greet with everyone. We kind of apologize for that. Actually, there was one guy though.
Yeah.
Your friend there.
I actually walked out to the car late at night to unplug it because I didn't want to get idle fees. And there was a guy sitting in one of these spots named Greg in a black Model 3. And he's like, "Hey, I saw you were in Clemson on Twitter, and I live in Charlotte, and I was driving this way, and I was trying to catch up with you." So I'll interpret that as he's a big fan. But yeah. I did get a picture of Greg. Maybe we'll throw it up there and work it into this.
Yeah.
Hi, Greg. Thanks for saying hi. But Clemson University is really pushing the envelope when it comes to their master's program. So we got a tour with David Clayton.
Yeah, the executive director of Clemson.
Yep.
So thank him an awful lot. By the way, Billy Morris was the one who kind of brought this all together. There was a communications gap, and we thought we were going to miss out, and Billy kind of jumped in there and arranged everything.
Yeah.
So thanks a lot there, Billy. You did a great job. Thank you.
We don't want to spill too much beans because we got 20, 30, 40 minutes worth of footage inside that facility.
So this is CU-ICAR. Now this is a part of Clemson University. Of course, we're 30 minutes away. It's one of the innovation campuses of our university. Mm-hmm. It's 250 acres, so we have the Department of Automotive Engineering is what you're kind of seeing here. We have 19 companies on campus. So BMW is here with an IT research center. We have Koyo J-Tech, Sage Automotive Interiors. They make textiles and fabrics for the cars, and a bunch of other companies. So it's both a research park for the corporate world, and then also an academic home for the Automotive Engineering Department of Clemson. So a lot of the buildings that we have on this campus are corporate tenants sort of occupy and work with the university. But the Automotive Engineering Department is probably the most successful graduate program as far as growth over the last decade here. So what is it now, Rob? 230 students?
Yeah, it's right around there.
Right around 230 students.
PhD and master's.
And it's only graduate, so master's and PhD level. And so what this Deep Orange project is, the master's students are pursuing this. So a cohort of them, 30, 40 sometimes, will build these cars over the course of 2 years. But when we go across the street to the Campbell Graduate Engineering Center, you'll see a lot of the research that's happening. So this is a student project.
Yeah.
Then there's a ton of research happening in powertrains, autonomous vehicles, manufacturing materials, and so on. So we've this is sort of the tip of the iceberg, and probably the most public facing and kind of the coolest thing that happens here is certainly this Deep Orange program. But. These are two kind of legacy now Deep Orange projects.
Deep Orange 3, that was 10 years ago at this point. And then this one they worked with the Art Center in Pasadena.
California Art Center?
Yeah, and to do the exterior design, and then we were doing the interior. Here's a nice feature. You probably haven't seen a door open this way in a while.
Yeah.
The chassis was made out of industrial origami. They were trying to figure out how you could make a profitable vehicle at low volume. So it was one machine that could cut everything, and then it was all hand folded here, which wasn't super fun, but they made it happen. And
we used to call those a strip it punch.
Yeah. And then
the touchscreen early prototype, right, from about a decade ago. So.
Front engine, it was electric rear, it was a through-the-road hybrid in this case, and they had, it was a whole, gosh, I hardly remember the story anymore about the, it was for the it was Gen Y, I guess, and that they like to bring all their friends with them. So
It's a social
set up
coupe.
the front seats, and that the one front seat was actually a little bit further back, so that way you're not bumping into each other in the wrong places, I guess. And this kind of stuff they had to think about and figure out how to package the human beings in the vehicle. And then this is one of the it was the third one we did, right? And that was Deep Orange 6 over there, which was for Toyota, the bigger vehicle. And we started thinking about, that one's all electric, trying to think about how you could run a business out of your vehicle. So it was, you know, you could plug into the battery pack. Of course, you see all this stuff today. It's pretty common, but you could plug in and you could run a business out of that vehicle.
Change the color, and it looks like a Cybertruck.
Yeah, I call it "What's the teal?" So,
Well, that was another
these pillars that the designers came up with, but you had to be able to see through them, so that it wasn't a big issue. Of course, this was one of the chassis we actually built here. You know, had the molds built and everything, and built the body panels. I think we did partially here. But we slowly built up capability over the years, and we farmed some stuff out to be built, and just because we don't have the capacity to do everything.
Yeah.
But so the kind of projects we like to do, pretty fun. We'll see a couple more if you want to come out in the main part of the building.
This carbon fiber protrusion and the customizable head, display elements, you know, the dash with 3D print your preferred color kind of ideas.
Yeah. That's pretty good for a student project. I saw much worse with people trying to say that they're professionals.
Yeah, we didn't want you to inspect our fit and finish, but you know, we're trying. You know, it's the first thing they build, right?
Prototype.
You start somewhere, right? And that's where it all starts. And we feel like it's a pretty unique program. You know, that you just don't find anything like this out anymore, and you need it, right? It's just so hard to find people.
They've taken a lot of the
a computer too,
for sure. Yeah.
So what's this one here?
This is so this building is education and research, right? So that's a vehicle. And I'm sorry, it's dirty in here. We have construction. We're building new test cells down at the end of the hall.
Oh, very good.
They were concrete cutting a day ago, and you just got stuff everywhere. It's a mess. But that's from autonomous stuff, and we use it to work on. We have a software team that basically writes driverless vehicle software. So the vehicle itself is working as it comes in with all the by-wire systems, and then we have a research group or a research team that work on the next generation of software that will go in there.
Part of the expertise is the full vehicle engineering. So a lot of universities, they focus just on the software, just on the compute, but really the vehicle dynamics and the integration of as a system, right? How it can respond and react. So that's what the capabilities of this vehicle bring, and then the test cells like
we can walk this way. Maybe
chassis
So
dyno.
what's the story with this one here then?
We mostly just, it was our first electric vehicle here, I think.
Is that right?
2 years ago, yeah. We just use it, our technicians use it to pull things around. It's nice to run in the building, but it's basically a golf cart. And it's actually a 72 volt or something, and it has inverter and everything in it. It's not and we actually will use it for our class labs because it's very easy to instrument. But we're trying to get some newer stuff going. I can show you some other things here. We have, if you want to come on in. Sorry, we're in a little bit of a repair work here.
So this is Rob's car.
Yeah, this was Deep Orange 9. We just
drive.
were running a bunch of cylinder pressure work on it with my class. But it's a through-the-road hybrid rallycross car. So this one has been beat up a lot, but it was a project with Honda and Eischen, JTEC, BF Goodrich. SEMA helped us as well. Yeah, we had Red Bull as a sponsor too. But they were trying to come up with what would be next gen in rallycross. So it was hybrid at the time, made sense, and trying to figure out how to do semi-active suspension. So it had, they're not in there right now, but it has the active roll bar system, anti-roll bar system from Eischen. We have active springs and excuse me, I'll walk right behind it. Yeah, you can get in it if you can, but I have a hard time getting out of it. So
if they crawl in the window, I'm out. But does this work?
Oh yeah,
really?
Yeah, it's rough.
It's going to be.
Yeah,
close.
It's really hard to get in and out of. You
Oh,
don't
really?
have to. It's okay. One of the fun features on this guy, it's a rear engine now. or mid, or however you want to call it, and then you know, they wanted to do, and this layout is really was all we could find at the time. It's kind of a mess, but it's UQM motor, and it would do like
inverter.
Yeah, it's huge now, right? This is like 6 or 7 years ago at the time. For the power level that we want, I think it's about 140 horsepower in the front. And it's a single speed, so it was really there. We wanted, students designed to put it in the front so that it would absorb the most regen braking, right? And then also the engine has about 3 times more power, so as it launches, it transfers weight backward. You can accelerate harder. The car was 4-wheel steering. They had to go through and justify why we would do that, because especially in the low-speed corners, you could go through them faster.
Yeah.
That kind of stuff.
And you can get tighter as well if you're going off-road.
You got
kind
it.
of.
Yep. Yeah. Yep.
Yeah.
The main thing, though, I mean, the car's a car, but it's all of the signatures on the roof that we enjoy. Those are all the students that worked on the car, and that's kind of the fun piece of it. They go all over the auto industry. They're all over the country and all over the world now, actually. So this is really what it's all about. The car is just there. We have a huge cell here. Actually, the battery only filled. There was only like 20. I think it was like a 23 kilowatt hour cell
Battery
pack, LFP chemistry, and then most of the front was empty. But I don't know if Anshul followed us. He didn't. But Anshul was the guy that had to lay in there and weld the whole thing together at 2 a.m. Not very fun. It had a dual catalyst system because we were trying to show that you could make a racing vehicle relatively clean. It had the old school air pump and all that in it, and but it was a good project. This one had about I think it was 28 students or something like that, and as it ended.
You raise a good point about the student results. I mean, that's what it's at.
Yeah, it's really what it's all about. A car's a car. They're fun.
You get to use it for labs now.
Yeah, we use it for labs.
Students get an educational opportunity off of it.
So we run our data acquisition systems, teach them about data acquisition. This one has a lot of combustion variability, that kind of stuff, to learn about that, and calibration. And let's keep walking this way.
Well, and the students, I mean, they've had a 95% placement rate coming out of school in industry. So that's where they're finding jobs at Ford and Tesla and Rivian, and of course BMW here locally. That's
well, it's going
they come to learn, but they come to get jobs too, right?
Well, that's the other reason we're here too. Hopefully, we can talk about that a little later.
Absolutely, yeah.
We're definitely looking for people. Oops.
This is our construction projects over there, but we have.
Wow.
Wait for everybody to come on in, but. So this is a full transient AVL dyno cell. We have, we're doing mostly heavy duty engine work in here right now. It's actually an engine we probably can't put on there down there. That's an engine for Acadi's Power. We probably can't show you that one, but this is just a standard engine. Here they're looking at ways to use artificial intelligence to more rapidly do onboard diagnostics, essentially. It's a big challenge to figure out how to determine if there's a fault on the engine. They're trying to figure out if they can do that faster with some of these new methods. We run, obviously, transient drive cycles in here, emissions, combustion work still, a lot of control work for heavy-duty vehicles, and then we'll also do hardware in the loop, so we simulate these engines in electrified powertrains as well. We're building another test cell similar to this next door that will allow us to have more hybridization in it. And then there's yet another cell that's going in next to that that's going to be all electric, a full electric drive cell with battery simulators as well. So we have smaller battery simulators around in the building, but now we're going to have a full-size one, moving more and more in that direction. We have environmental chambers and everything in there for the cells, all of that kind of stuff. So that's trying to have the full-scale capability. And then we're also working on connecting all of our cells together here and on our main campus. We have some fuel cell work and things going on down there where we can run portions, all of it in real time, but we can run portions here, portions there, and have them all communicate over the web really quickly so that you can run a very expensive, rare piece somewhere else. You don't have to transport it here and integrate it in. You can just run it in its very specific test cell and run it as if it was in a powertrain, a real powertrain. So we're doing a lot of that, and then of course we do work with for the Department of Defense, and in there you could then have a gadget sitting elsewhere that's operating. We don't even really know what it is. You can send us information, like what is its electrical load or whatever it needs, and then we can simulate how the rest of the powertrain would operate around that. So we're doing a lot of that kind of.
So what do you see as far as hybrid? I mean, is there a growth in that market for you, or?
For off-road, yes. For off-road, yes. For the U.S. Army, for sure. They had, because there it's high, super high power levels, sustained power levels. Full electric does not make sense yet, you know. And I don't know in the issue of charging and all that. They have, you know, they're just not there yet. And so we do a lot of off-road, especially tracked vehicles, because the steering torque is really important there. It's a much more difficult problem. So we're doing mostly hybrid around heavy duty. And then there are heavy duty line haul long Class 8 trucks as well. We have some work going on there. And
what about automotive or light truck? Like
we're not doing too much really. Right now we're pretty saturated in heavy duty and our U.S. Army work that we're doing right now. We used to do a ton of mostly IC engine work around control and about getting these super complicated engines to market faster. So more or less trying to eliminate calibration. Can we use these model predictive control strategies or some kind of AI-based system to you know, with a ton of data involved, right, and train control systems faster.
Right.
That was the work we were doing recently, and now we've pretty much switched. We have a pretty healthy relationship now with U.S. Army, and it's kind of switched us over almost exclusively to that work. There's just, we don't have enough people at this point. We can do a lot of work. A lot of our students go off to the companies in California these days, the passenger car companies, the Rivians and that kind of stuff.
Climate is much nicer.
Yeah, it turns out, They used to, a lot of them would, you know, a lot will stay here in South Carolina, but then a lot would go to the Midwest, and then now it seems like the bulk of them go to the West Coast. That's kind of the new area. You get great offers.
Phenomenal offers.
The real estate market's a little rough.
But the real estate are, and actually, we had 2 people quit and go to Rivian and came back. 2 months. Took one guy 1 month, one guy 2 months.
I think so. There's a new AVL cell that's going to be in there, another one there. We're actually going to upgrade the chassis dyno as well, and that will have. I can't say too much on camera about that. It's going to have some new capability around driverless vehicles, and to say it that way, and how you can get miles on vehicles faster.
Over here is going to be a lot of battery testing, charge, battery management systems. And,
do you have an alliance with any of the battery manufacturers, or?
You know, we certainly do research with several, but we can't, as a state institution, we don't have, you know, how to best put it, exclusive alliances. So if that makes sense,
No,
These labs are just advanced manufacturing work. We have also you want to talk about the CMI maybe a little bit too?
Yeah, I mean, I can talk about it. I probably don't have time to get over there, but so next door behind us, we have a partnership with Greenville Technical College, and so it's a 100,000 square foot building. They do all their machining and mechatronics and industrial maintenance training. But over there, we've kind of bridging the gap between associates and bachelor's degree into the research of master's and PhDs. So we have 2 massive labs. One is a full-scale vehicle assembly center. We can get you some footage or photos of this if you're interested. But basically, we have, you know, a full-body BMW vehicles on there now. It travels along the line, and that's where research is happening on human-machine interactions in the manufacturing plant. You know, collaborative robotics, all the next-generation technology, and really assembly of automobiles. You know, making electrical connections and things like that.
Yeah.
And then the other part of the lab is a composite center. So this is a 1,000-ton HPRTM press, high-pressure resin transfer machining, to make carbon fiber composite parts at volume, you know, at the price point, and at the the throughput or cycle time that automotive needs. So rather than the hand layup type carbon fiber robotic layup, this is, you know, high speed. You're already seeing it in some BMWs and some other vehicles. You know, a 3-minute type cycle time is what they're trying to achieve, maybe 2, to really get the
60 seconds would be what I'd really look for.
Absolutely.
Otherwise, you need 3 of them.
Yeah.
That's right.
But
so AVL, one of your customers? They're one of our
we
customers.
purchase a lot of this. We have a good partnership with them. So we have their control systems. We connect all of our cells together with their software.
Yeah.
And then they're working with us to do some of the stuff in the chassis down. Also, we're becoming, I guess, a kind of a development area for them in the southeast, at least. They've liked us for sure.
Cool.
Yeah, we use them a lot. Their test equipment is outstanding. So it's hard to argue.
Yeah.
We'll keep going. There's a single-cylinder engine lab here. We still do some advanced combustion work, especially on really thin coatings on pistons that can rapidly change temperature to try to improve combustion efficiency a little bit more. And like they get about a 0.5% efficiency gain on diesel engines. We just saw really design their coatings that can be porous and then just vary throughout their thickness. And they're super thin. They're not really thick insulating coatings.
What did y'all finish in that competition?
So we actually didn't race. So this is Deep Orange 12. We designed with Delara, we designed the driverless race car for the Indy Autonomous Challenge. So we designed the common car. 10 of them were built and then raced, but we could not race because there was a conflict of interest.
What?
To race, to design the car and then race it. So the teams asked us not to race. But we went through as Deep Orange 12. We designed everything in the cockpit. We integrated a new engine, a new structural engine in the vehicle. And then they raced for the first time in October at Indianapolis Motor Speedway. The top speed was like 157. I think the highest lap average was right around 140. And then they're actually out practicing at Las Vegas Motor Speedway right now, literally right now. And they're going to run at CES or during CES on Friday during CES. If you're out there,
Yeah, I am.
come out to the race, and you'll probably hear my voice over the announcing.
Rob's announcing the race.
Again, I had to announce the
Really?
first one. I'll be announcing that one. So there are 9 teams from around the world. They're there. TU Munich just went 150 around that place yesterday, so they're starting to speed up. They're actually going to go and start passing each other. They're going to have multiple cars on the track. And
So their
it'll be
lap
a
time
cool-
was 150?
They hit 150 yesterday. They're going around. Yeah,
wow.
TU Munich
That's
did. Yeah, they're
fantastic.
really flying. So it's pretty encouraging.
Yeah.
So it's just a new type of racing, right? It's it's similar in many ways to current racing, where you kind of the vehicle has to make all its own decisions, right? It's not remote controlled. There's only just some communication between the pits and the vehicle from a safety point of view, and that's it. Just flag status, shut the engine down, start the engine, whatever. That's it, and they are off and going.
So Clemson's role in this is really kind of underlines a point I made on that other car, is that it's the full vehicle engineering that we're good at. And the other schools have put their software in our car, but of the 10 vehicles that were produced, all of them have a Tiger Paw on them, so we're pretty proud about that.
If you look at the front of the car on the real race, the official race cars, you'll see Clemson right on them, on every one of them. So, yeah, it's been a great project. We had about 39 students on this team. This was the first one to really go into production, right? 10 of them were built, and so that every drawing had to be right, so that it could be made. That was a pretty big learning experience. It had a smaller scope in some ways, but the level of detail you had to make it through, because it was more than just one prototype, was really a pretty difficult challenge. And we tried to design it so that it was very flexible, because all of this driverless, the perception systems are all evolving so fast that next year it'll likely be a different sensor set, or at least different sensor suppliers with different capabilities. So we had to go through and figure out what are all the field of view, the field of views that need to be there, how fast all of the sensors need to be, at what range they really need, so that way if something's in the track, you have time to actually avoid it. It's a pretty difficult problem to go through all of this, and of course COVID hit in the middle of it, so it kind of slowed everything down a little bit, but it's been successful. After the first set of racing, they had a whole bunch of new sponsors that came in, and the series looks pretty healthy at this point. So we'll see what happens. It's a 7-post shaker rig in here. I can turn this light on real quick. So this is a 7-post shaker. Actually, we're going to have it in 4-post mode soon only. And then it's an environmental chamber, so it can go from I guess about minus 40 Fahrenheit or minus 40 C, they're almost the same, up to 90 C or 190 or so Fahrenheit. And then it has humidity control within it. And then the hydraulic shaker system under the floor. This is going through a software upgrade right now. but it's a pretty unique facility in that it has the environmental chamber and the shaker. This is just a buggy that it's actually gets on its way out, but gets instrumented for our students. They learn different types of instrumentation. They'll put it on the buggy and go run it. They'll model the vehicle and then, validate their models with the sensors. Like you see, they've had little accelerometers kind of all over the vehicle, just trying to validate models, learn that piece of it. This is really a class project, educational piece. Learn about wiring, these kinds of things. This vehicle is going to get sunsetted and it'll become something different here pretty soon. But just a fun thing, easy to work on, fun to take out and run off-road a little bit.
Yeah.
We have I think broke, but another dyno cell there. That's actually getting converted to run a hybrid powertrain, similar to what you saw across the street in the Deep Orange project. So we'll actually have the hybrid powertrain in there, so our students can start working on the control system in there before the actual vehicle is done. So just trying to help them work in parallel on their development. And then we have advanced control work that I'm not sure where Dan is, that Dan is working on, that also will be demonstrated in there. We do a lot of modeling and simulation work, but you really have to balance it with experiment, right? Otherwise, nobody believes the simulation unless it's actually validated, right? And so that's really what we push to do.
Yeah.
So, it's hard to do that. It's expensive to do that, but it's important, right?
Well, emulation versus simulation. People want they want to see it working. They want to see something made out of tin or whatever. You know?
Don't want to keep you too long.
We have labs for our structures classes. We do modal analysis and everything on the vehicles. That was actually a chassis left over from Deep Orange 9. We had an extra Civic. You could probably go through and tell us a lot about that thing.
Actually, Corey is the one who could tell you about a Civic. I didn't work on them, but Corey's worked on hundreds of products. Yeah.
Yeah, and there's a driverless golf cart. There's just a simple way to make to work on software, right? You get low speed. The Deep Orange 10 project, which you didn't see, it's in the airport here right now, but it could park itself. So they were practicing their software on this vehicle. It's a really low risk way to work on driverless vehicles, right? So.
This is our project. This is the club car precedent, and we did this soup to nuts. Everything from customer complaints and whatnot all the way through to the first 500 car build, and then the factory and everything else.
Really?
Yeah, this is one of our patents. They gave me I don't golf. What a surprise, huh? Anyhow, I was sitting over there and they were driving me around in Georgia, Augusta, and it was raining, which it does, I found quite often in Augusta, and the rain was coming off the roof of the old product, and the tumble home made it go right into your lap. I was getting wetter sitting in the seat than if I would have been outside. And I said, "Why don't you guys have a gutter?" And they said, "What's that?" So this is the gutter, and then this is the downspouts. So at the time it was like revolutionary, and that was the first patent that we applied for. Yeah.
Cool.
And we took them from 32% market share to 80 in 1 year. Yeah.
The gutter, I mean, that's sold, right? I mean, yeah.
Oh, that was at one time it was 15% take rate because nobody could make one. It had a patent on it. And so 15% of the products that were sold simply because people didn't want to get, well, it was for two reasons. One, you didn't get the passengers wet. Right. But number two is, I don't know if you noticed it, but these wheels in the front are inboard of the ones in the back, and the reason for that is so that they don't track on top of each other, and that way you don't make ruts. And the water going down and inside and in back, that's another way to keep ruts. The gardeners or groundskeepers, they don't much care for ruts.
Right, right.
And neither golfers, from what I'm told.
Yeah.
Going into a trough is bad for golfing. Yeah.
That's great.
Fun.
Yeah,
So
cool.
Yeah,
So-
for us, it's just a easy,
Just another
easy,
box.
safe thing.
It's
Yeah.
a platform.
You know, a lot of approvals to get people to go out and drive it. So,
Yeah.
we have a car. We just they actually just took all the ride height sensors and slip angle sensors, wheel force sensor, all that. We were doing vehicle dynamics labs with our students, and they're going to take it to the autocross, I guess, this weekend too. So we took all the sensors off of it, and then another vehicle where they do a lot of autonomy work. It's just a mule vehicle that is set up with just different systems. These 80/20 racks, you can put anything you want on them and go out and try different algorithms out and drive around.
Cool.
We actually recorded a bunch of data at Indianapolis Motor Speedway for the GPS lines that they were running
Yeah.
ultimately in the driverless race with this vehicle.
Yeah, the faculty and students outfitted this one completely on their own, so
Yep.
it was a
Yep.
pretty big project.
There's more manufacturing work. I mean, there's just it's a lot of everything. And then upstairs, a significant amount of simulation is cube farm essentially. But then people like Dan will use the cluster, the Palmetto cluster. How many teraflops is that? Is it 15 or something?
We have access to more resources
Yeah.
than we need
Yeah.
to do that, so that's very handy.
Mm.
Yeah, I can solve problems I can't solve on just a desktop through the institution supercomputer.
Another lab that's up there, it's way up there, but Janelle Brooks, so she's a psychologist on our staff here, and so she
Really?
does human factors and driver safety, a lot with
Yeah.
teens or folks with disabilities and ingress and egress and driving under those conditions. So it's kind of a full spectrum, right, that we have as far as talent, which is it's a
Just,
point, I guess, about the department itself of automotive engineering, it being really the first one in the country of its kind.
Yeah.
Everybody came from different disciplines, mechanical, psychology, electrical and computer, even material science. So it's multidisciplinary in that way. Yeah.
Well, I have a little saying. It's 10% technology and 90% psychology.
Yeah.
That's how you make a real product. Yeah. Yeah, cool. I'm very impressed. Yeah, very nice to see all these kinds of projects going on. I guess I had no idea. Well, I had some idea. Billy told me quite a bit about what was going on. But seeing's believing, right? It's like Deming used to say that all the time.
Right.
Yeah.
We've got more coming. Another building going up
Good.
in January, and student count keeps growing.
Yeah.
More faculty.
Yeah, keeping
So-
us busy. Keeping us busy for
A
sure.
lot of faculty coming in the manufacturing space, 3D printing, additive manufacturing
Yeah.
for vehicles,
Yeah.
composites materials,
Yeah.
Yeah.
and then electrification, of course. So, yeah.